So in this video, I am doing a truth table to verify whether or not an argument is valid or invalid. The initial premise was not P if and only if not Q. The second premise was Q then R, if Q then R. And the conclusion was if R then P. So to construct a truth table, I first made a column for each of my simple statements P, Q, and R. So let's fill those out. For P, Q, and R as your three simple statements, you'll have 2 to the third, since there's 3 simple statements, or 8 total rows. So for each of these rows, we'll fill out our appropriate columns. So for the P column, half of 8 is 4, so we'll take 4 truths. I'll use green for true, 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 followed by 4 falses. I'll use red for false, 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 false. Okay. Now I have the P column, which means what I really need for my first premise is a not P here. I could negate that column if I wanted to get ahead of myself, and I'd simply take every true and turn it into a falsehood, so T becomes an F, and every falsehood becomes a truth. That's the opposite. That's what negation does. So that's the first part of premise 1. We needed the negation of P. We'll also need the negation of Q, but before I can do that, I need Q. So what is Q? Well, if P was half true, half false, so 4 trues and 4 false, remember that Q is 2 by 2, true, true, false, false, true, true, false, false. So I'll do green for true, 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 then I'll do red for false. Grab that here, false, false. Then I'll do green for true, true, true. You don't have to color code as much as I do, but I really like keeping things simple for myself. And then red for falsehoods. There we go. Okay, so now I'm almost able to complete premise 1, which I decided to label in pink to keep things organized here. So for premise 1, I need not P, if and only if, the biconditional here, not Q. So if I have the Q column, I can get the not Q column by simply negating it. So instead of a true, I put a false. So for the first 2 in this column for not Q, we have false, false. But instead of the 2 falsehoods for the original Q, the opposite of false is true. So these are true, true. And similarly, instead of these 2 truths for Q, for not Q, they'd be 2 falsehoods, wouldn't they? False, false. And again, instead of these 2 falsehoods, the negation of that would be 2 truths for this not Q column to complete. So now I am ready, technically, even without completing the R column. Notice I'm ready to complete the premise 1 column, which I put in pink, and I'll later refer to as capital P1, premise 1. So for this premise 1 column, which you can write P1 on top if that's easier for you, instead of color coding it. For premise 1, notice that the symbol connecting the not P and the not Q is if and only if, the biconditional, which means, again, this statement is true if both of these original statements, not P and not Q, are the same value. So if this is true, this must be true. If this is false, this must be false. So they have to be the same. So we look at the not P and the not Q column side by side, and we say, when are they exactly the same? Well, that happens in the first case, doesn't it? They're both true, so I'm going to put a true. It does not happen here, right? I'm sorry, I said that backwards. It does happen here again. These are both the same. So this again would be a truth. But notice it does not happen in the third row here when I'm comparing not P with not Q. They're different, aren't they? So this would be a falsehood. Again, they're different in the 4th row because they're not the same. This would be a falsehood. Again, they're different in the 5th row. So this would be a falsehood. And they're different in the 6th row, another falsehood. But at the 7th and 8th rows, now they're the same again, aren't they? So truth and truth. So that is premise 1. When we're talking about not P, if and only if not Q, when does that happen? If we have true, true, then 4 falses, and then 2 truths. Okay, hold on to that. Let's head over to what premise 2 needs. Premise 2, which I'll put in blue and later referred to as capital P2 for my convenience. Premise 2 was that Q happens, forcing R to happen. If Q, then R. So Q is the antecedent, and R is the consequent. If Q, then R. Okay, so I need a Q column. I have that right here. It was my second column. But I also need an R column, and that's why I built this truth table in such a way that I would have P, Q, and R side by side. So for the R column, instead of going 4 by 4, then 2 by 2, like we did with P and Q, we'll go 1 by 1. So we'll go true, false, true, false, true, false, true, false. So I'll use, again, green for true, red for false. If you don't mind, I'll just skip here while I have this marker open. So every other one is true. And then starting with the second one, every other one is false. So false, skip, false, skip, and then false. Okay, so there is my original R column. Notice I don't need a negation of R column here. I could do it if I wanted to, but the actual premises do not ever ask you for negation of R, so I don't need to do it unless I want the extra practice. So for this column, for premise 2, I say Q then R. That means I start with the letter Q, which is this column, the second column, and I stop with the letter R, this guy here, the third column. Now for an if then, not an if and only of the double arrow, but the single arrow to the right. Remember that the only time that an if then, a conditional statement, is false is if the antecedent, the first part, is true, but the consequent, the second part, is false. So the only time that an if then is false is when I have T and then F. In other words, your expectation is not delivered with the true condition met. So the condition is met, but then you don't fulfill your promise. So T and then F is a falsehood. So let's see if that ever happens. I'm on the lookout for a falsehood, looking only at Q with R here. Do I have any falsehoods? A T followed by an F. Not here, but in the second case I do, don't I? A T followed by an F. That's a falsehood, so I'm going to put my falsehood there. Any other times I have a T and then an F? Nope, that's an F and then a T, so the condition wasn't met, so you can't call me a liar. Can't call me a liar because the condition wasn't met. Here the condition was met and the promise was delivered, so that's true. But here the condition was met and the promise was not delivered. This T and then F is a falsehood. Again, here the conditions weren't met, so you cannot call these falsehoods. So the only time where premise 2 is going to be a falsehood is in row 2, and it looks like row 6. Every other time, you can't call me a liar in that premise. So we call them true. Okay, so now we have premise 1, which was negation of P, if and only if, negation of Q. I put that in pink. That's going to be called premise 1. And then premise 2 was Q then R, if Q then R. Put that in blue, and I call that premise 2. When you're trying to prove if an argument is valid or invalid using a truth table, remember you need a column for each of your premises. Good job, we did it. Then you need to say when both of these premises are true, so if P1 and P2 happens, does your conclusion follow naturally? So we need a conclusion column, so I also make a column for the conclusion, which was if R, then P, and I put that in purple. Okay, so let's go ahead and first put the premises together. Premise 1 and premise 2. You're welcome to write it all out or just use shorthand like I did. This and this. Premise 1 and premise 2. So looking at those two, for an and, do you remember when an and statement is true? When would these both be true? If each of them individually was true, that's correct. Well, that happens in the first case. They're both true. So we'd say both premises are satisfied there. But in the second case, only one of the premises was true. So in your argument, you're building this argument, one of the premises is not even true. So it doesn't matter if it leads to the conclusion, the argument wouldn't make sense. So we ignore that one for now. That's a falsehood. Again, both premises are not true here, or here, or here, or here. It's not going to happen again until the 7th or the 8th rows. So we would say that we would only be true in rows 7 and rows 8. So here, every other row is going to be a falsehood. So we're going to put our F's there in red, just for convenience. And now we're at the point where we can finally make our conclusion column for the truth table. For the conclusion column, we want to take R, then P. R, then P. So if R, then P. Look at our R column with me. Here it is, that third column. And then look at my P column, the first column. Now the order matters for an if-then. Remember we did an if-then earlier with our second premise? We said that an if-then conditional statement is false under one condition. It was only going to be false if the antecedent was true, but the consequence was false. So the condition is met, but the expectation is not delivered. So let's see when that would be false. Let's look at R first, P second. The only time that's false is when I have a truth followed by a false. But let's go in the right order. We're going this way, aren't we? R, then P. So T, then F. Do we ever have T and then F? Not in the first row. How about the second row? T and then F? Nope. How about the third row? T and then F? Nope. How about the fourth row? F and then T. No, that's not TF. But here we have it in the fifth row. We have T followed by F. This would be our falsehood, right? It happens again later on in the seventh row. T for R and then F for P. So that would also be a falsehood. Those would be the only two times where the conclusion is a falsehood, where the condition is met. So R in this case is true, but the conclusion P is false. That happens in rows 5 and in 7. Every other time we would say that the conclusion would be a truth. If it's not false, it must be true, right? They're one or the other. We have two options there. All right, so now we're almost there. We notice that we have the last column here, and this is when we finally get to the meat of the problem. We have the premises, 1 and 2, so now we know when each of the premises were true. We know when they're both true, which happened in the first case, the 7th case, and the 8th case. So those are the ones that really matter, okay? And what we're trying to see is when all the premises are true, which happens really here, here, and here, does a conclusion follow? Is it true? In the first case it is, in the last case it is, but notice in this 7th case it's not. In other words, what we're really looking for is when you put the premises together, which we did here, do they imply the conclusion? In other words, when you have a truth, do we get a truth? So when the premises are true, do we get a truth? We do in the first case, we do in the last case, but notice what happens in that 7th case. We get a falsehood because if it's an if-then statement, premise 1 and 2, that's an arrow. Do they imply the conclusion? In that case, when the premises were both true, they did not imply the conclusion because it was a falsehood. That's technically enough to stop the problem because in all of the other cases, remember, for an if-then statement, if the premises are true, do they imply the conclusion? We don't even have the premises being true together here in these cases, so we can't determine anything. We just say, we can't call it a liar, can't call it a liar, can't call it a liar. So those ones are considered truths by default because for an if-then, one of these if-then situations, the only time that we can call an if-then statement a falsehood is when we have a truth and then a false. And that only happens in the 7th case. Notice in that 7th case, because we have a falsehood, we would say that this if-then statement, P1 and P2, then C, conclusion, this is not a tautology. If this is not a tautology, that's really saying that your premises, even if they're all true, they don't always force the conclusion to happen. We saw that happen here. They didn't force the conclusion to happen. So if it's not a tautology, we would say that the argument is invalid. The only time that this is a valid argument is if the premises, when they're true, always imply the conclusion. So if that had been a truth as well, then this would have been a tautology. It would always be true in that case, and we would have been able to say it was a valid argument. But in this case, the argument looks invalid by a truth table. Well, it's a lot of tedious work. It's easy to make a mistake somewhere, so I hope the colors helped you. And if you have any questions, you can email me at any time, and I'd be happy to help. Happy practicing, and remember, math is not a spectator sport. I'll see you next time.